Good morning to all. In the process equipment design 2 subject, we are discussing a storage tank design. Okay, so we discuss about the design of fixed roof storage tank. Okay, now, so in which we discuss the equation about the volume, that means a capacity, requirement a capacity, that is V. So this equation we already find it. Now, bottom design for the uh, रूफ स्टोरेज टैंक सो इसके अंदर सी सेक्शन इज अटैच विथ vertically and the section DD which is perpendicular and it is shell plate which is connected with a bottom plate. Okay, now and the overlapping, that is section in the section number C जहाँ पे क्या होता है ओवरलैपिंग होता है रिंग को जोड़ने के लिए. Now in rare case, bottom plates are also joined by a single welded butt joint with backing strip. ખૂબ જ ઓછા, in few many cases there is a requirement of a place plates are joined by single welded joint by within a backing strip. Now, bottom plates are fully supported by concrete slab or by a consolidated and leveled ground. બોટમ પ્લેટ છે એને ફૂલ્લી શાનાથી કરવા જોઈએ? કોન્ક્રીટનો સ્લેબ જે હોય છે ને, ધેટ મીન્સ કે નીચે જે બેઝમેન્ટ બનાવે છે એની વાત કરીએ. વેલ કોન્સોલિડેટેડ એન્ડ લેવલ ગ્રાઉન્ડના લેવલ સાથે મેચ થતું હોય એવી રીતે. બોટમ પ્લેટ્સ આર કનેક્ટેડ ટુ સેલ બાય વેલ્ડિંગ જોઈન્ટ. અને જે બોટમ પ્લેટ છે એને કઈ રીતે જોડવામાં આવે છે મેઇન પ્લેટ સાથે? તો કે વેલ્ડિંગ થ્રુ. Bottom plate is fully supported, but load acting on a bottom plate is not uniform, particularly in the area. હવે આપણે શું કરીએ છીએ? બોટમ પ્લેટને આપણે ફૂલ્લી સપોર્ટિંગ ક્યાં? તો કે જે બેઝમેન્ટ હોય છે, લેન્ડ, બરાબર, જગ્યા, એના લેવલમાં આપણે બનાવે, બટ ધ લેવલ through it is not considered as a the load is load on the bottom surface of the vessel is uniform at every point. No, but the load acting on the bottom plate is not a uniform, particularly in the area. Particular area ની અંદર કોઈ પણ જગ્યા પર લોડ યુનિફોર્મ હોતો નથી. In a vicinity of shell to bottom plate joint, some area is affected by liquid load and other is not. Vicinity of shell bottom plates are some area which is affected by liquid load and other load. Also, particularly in the case of large storage tank, particularly in the case of large storage tank of the ground may be not remain equal in all area. Okay, it is not equal to in the all area. જેમ કે લાર્જ સ્ટોરેજ ટેન્કની અંદર જે લેવલ છે, level of the ground not may remain equal to the area. So bottom plate may be coded by the liquid storage in the tank. So the minimum thickness of the segmental plates of the bottom plates is kept 6 mm. Okay, minimum thickness segmental plates, that is the segmental plate that is similar to the orifice plate, so which is having the small diameter. Minimum thickness of the segmental plates from the angular ring is formed 10 greater than 20 meters in diameter and 8 mm. 20 meters in diameter and 8 mm. Sometimes storage tank are placed on the height to facilitate flow of liquid from the storage tank, and the water storage tank like a building are normally placed at the height of the plant. In the case of storage tank which are supported to beams, minimum thickness of the bottom plate for the storage tank is required is given by this equation. This one is only informative, but this one is important. The minimum thickness for the bottom plate required is given by this equation. So it is TB 10 raised to 2 under root 3 uh, uh, rho HL square upon 4FB plus CA, where rho is greater of 100 kg per meter cube, अथवा तो it is the density of a fluid to be stored. जितना भी फ्लूइड उसके अंदर हम स्टोरेज करने वाले हैं उसकी डेंसिटी विच कंसिडर एन 100 kg per meter cube. Okay, 100 kg per meter cube. Then next, alpha. TB is the thickness of bottom plate in a centimeter. Thickness of bottom plate, we consider it is in centimeter. Okay. Now, h is the maximum liquid height in the meter. Height of liquid consider in a meter. Okay. So it should be considered in the meter. L, length of the bottom plate freely supported between successive beam in the centimeter. Next, FV, allowable bending stress that should be in kgf per centimeter square. And next, liquid ammonia storage tank is elevated to earth by say 6-inch height and supported on beams to reduce heat gain from the earth. Liquid ammonia storage tank is elevated to earth by say 6-inch height and supported on beams. That means for a particular section अमोनिया अमोनिया स्टोरेज टैंक अगर होता है तो उसके लिए 6 इंच हाइट कंसिडर करनी होती है, एंड देन इट विल बी सपोर्टेड बीम्स, उसको बीम सपोर्ट किए होते हैं फ्रॉम टू अर्थ सरफेस टू बीम. Now let's see a data for a cell design. Based on practical consideration, minimum thickness of cell plate given in various standard. Diameter is approximately 15, then minimum thickness 5. If the then diameter is less than 36 meter, then it will be considered 8 mm, and more than 60 meter, then minimum thickness is 10 mm. Now, to find out the thickness of any cell courses, first we have to calculate the value of internal pressure acting on that course is calculated by this equation. Okay, this equation is useful. So P is equal to R into H minus 0.3 into 10 raised to 2 plus P dash. P is the internal design pressure which is in kgf per centimeter square, and P dash is pressure in gas phase at the top in the kgf per centimeter square. R is the density of a liquid or a water whichever is greater than. લિક્વિડની ડેન્સિટી અથવા તો જે પણ અને પાણીની ડેન્સિટી બંનેમાંથી જે વધારે હોય એને કન્સિડર કરવાની છે. And h is the vertical distance between bottom shell of the core under considerations. That means lower end to the cell cores, top of the roof angle, or the bottom of any overflow which limits the tank's filling height. From the thickness of cell plate and any course is consideration is found by the equation, that is this equation, that is T equal to Pj Pd upon 2Fj into 10 raised to 3 plus Ca. Okay, this equation is for what? Cell plate of any course in considerations is found. So that is T is equal to PD by 2Fj into 10 raised to 3 plus Ca. F is equal to thickness of shell in mm. D is the nominal diameter of tank, which is in meter. F is the maximum allowable and tensile strength for a safe plate and material at atmospheric temperature. And P is the internal pressure acting on a body. T is the thickness of shell in mm. D is the nominal diameter in tank in meter. And then F is the maximum allowable tensile stress of cell plate material at atmospheric temperature in kJ per centimeter square. P is in internal pressure acting on that course, and J is the joint efficiency. 4. Double welded butt joint construction joint efficiency it should be 0.85, and a double welded full lap joint construction J it should be 0.75. Okay, now uh, wind girders for a large open tanks. Okay, so girders are useful for the wind uh, support to the vessel. એટલે કે ડ્યુરિંગ ધ વાઇન્ડ લોડ થવાના કારણે જે સ્ટોરેજ ટેન્ક છે એની સરફેસ પર એક્સટર્નલ શું કરવામાં આવે છે, રિંગ લગાવવામાં આવે છે, બરાબર. દેટ મીન્સ અ એડિશનલ પાર્ટ. તમે you are seen that in a photographs or industrial storage tanks, so in which there is a outer ring, okay, so for the supporter, and this ring is nothing but this one is for the wine grinders to large open tanks for the supporters of the wind loads. Okay, and it should be open tanks are not having a sufficient rigidity to withstand the wind load of a long time without deformation. So to prevent the deformation of a large open tanks under the effect of wind load, we have a two options. First, to provide the higher thickness of the cell, or to provide wind grinders to or a stiffening ring located at or near the top of the vessel. બરાબર, એને બીજું કહીએ ગ્રીડર્સ તો એને કહેવામાં આવે સ્ટીફનિંગ રિંગ. જે વધારાની રિંગ છે બરાબર એને કહેવામાં આવે સ્ટીફનિંગ રિંગ, જે આઉટર સરફેસ પર લગાવવામાં આવે છે. તો એ જે રિંગ છે એને ક્યાં લગાવવામાં આવે છે, લોકેટ એટ ધ નિયર ધ ટોપ ઓફ ધ વેસલ, and on the top course of the cell plate the stiffening or wind grinders is placed preferably on the outside of the cell rather than the inside. Second option is more economical because to improve thickness, અહીંયા આપણને સિમ્પ્લિફાઈડ કરીને જ કીધું છે કે સેકન્ડ ઓપ્શન બેટર છે. ફોર વાય? to provide higher thickness it requires the maximum cost and the difficult to design the storage tank. So better is that if you providing stiffening ring or the wine griders, so the resulting is that this one is the stiffening ring or a wine grider is placed preferably on the outside of the cell. So using this they can handle or the withstand the wine load. Required minimum section modulus of stiffening ring is given by this equation. Z is equal to the 0.059 d square h, where Z is the modulus of section, d is the nominal diameter tank diameter, and h is the height of the tank in a meter. Okay, in figure there is a number of various types of griders is given, that wine griders for the top of shell for open vessel recommended by API standard. Okay, and this standards is suggested by or recommended by the API standard, American standards. So these are the these types. detail A, B, C, D and E is given that. Okay, so which is having a different thickness and which having a different heights. Okay, so there is an limited types of the gridders available, the number of 5. Okay, available section modulus should be greater than the required section modulus. Available section modulus, it should be must be greater than. In the calculation, the available section products proportion of the cell to the tank for the distance of 16 plate thickness on both sides from the stifting ring is considerations. On the both side of the ring, it should be considered as a uh, stifting rings both side. Now in the next lecture we are discussing about the conical roof stalls or conical roof stand roof structure support.